All right, so we're going to go over the notes that you took on Bernoulli related to fluids and motion. So we will kind of be talking about this with a lab that we're going to do also in a couple, well, at least one video, but some more information. So Bernoulli was a guy who studied the airfoil, which is kind of the shape of what we now know as the airplane or the bird's wing. So that he said the pressure of a fluid decreases as the fluid's velocity increases. Now, we are also talking about air. Air is a fluid, not just liquids. So be careful as you think about that. Much of what we will address today has to do with air. So if we were in school, I would be able to show you this at our sink, but the ball is actually pushed. If you put a ball on a rope like that by flowing water, what happens is the ball is going to be pushed because the air is a higher pressure regularly and the water pressure is lower. So remember, things flow from high to low, so it's going to look like magic, right? It's going to be tipped and hit into the water. And so much of some of the sports we play, etc., will follow this rule, and we'll talk about that today. So an important part, obviously, to why an airplane can fly is because of the shape of the wing. It's not the only thing, but it's a big piece. So airplane wings are made so that the airspeed above the wing is faster. It travels faster. It gets there first, so to speak, at the back of the wing over here. So when we look at this air is traveling faster, and because it's traveling faster, it ends up being an area of less pressure, and so it creates what we call lift. So it says airplane wings are made so that the airspeed above the wing is greater than below. According to Bernoulli's, that difference in airspeed means a difference in pressure. So you have that upward force that contributes to lift. So another feature of the wing design is that the shape of the wing forces the air downward. So it pushes the air upward. So there's two pieces to that. So they're just kind of showing you that. We also have lift, right? That's that upward force on an object that moves. So it's some of the terminology that we need to address. And that air above the wing ends up moving faster, so it creates less pressure. The air below is moving slower, and so there's more, and remember, high to low. So the greater pressure below the wing exerts that upward force. So there you have how an airplane flies, kind of. Thrust is another piece. We use engines for that piece, which is the pushing or the pulling force. And usually that is related to some type of engine when you get into, or several engines when you get into larger aircrafts. So lift is determined partially by the speed of the air and that travels over the wing, and then the speed is determined by, of course, the engines, the thrust of the engines. So there's a couple different wing shapes we can mess with, right? And you can look at the angles and all of that. That gets a little more complex, but there's a lot to that, and we're going to take a couple different points to look at in our lab. So speaking of sports, we talk about the screwball, the curveball. Those all use pressure differences. It's pretty amazing. So if you are familiar with how a curveball, screwball works, it deals with the difference. So if you look, this is a screwball. So the airspeed on the left side of the ball is going to be lower. And then because of the spin on the ball, right? And then there's a region of increased pressure on the left side because of that. So the direction of the spin is as you can see, the blue arrow is kind of the air, and then the purple in the middle is the direction of the spin. So the ball's spinning this way, and the air is traveling, obviously, that way. So the airspeed on the right side of the ball gets increased because the air around the ball moves in the same direction as the airflow. So there's a region of decreased pressure on that right side. And of course, because the air pressure on the left is greater than on the right, the ball gets pushed towards the right because it wants to go to an area where there's less. So it looks like it's coming in straight, right? And at the last second, it gets pushed towards that right side, or the left side of it depends on which side you're looking at, but you see the curve and it moves away from the home plate where the batter thinks it's going to go. So it's kind of a neat phenomena that if you're a very good pitcher, you can make that happen. So drag is the last piece that we talk about when it comes to that airfoil. So, or the why an airplane flies related to the airfoil. So the force that's parallel to the velocity of the flow, it opposes direction in an aircraft, and with the thrust, it determines the speed. So when you think about it, drag does happen, right? You can create drag. There's cars that do that with, that are super aerodynamic. They have those spoilers on the back if they're race cars sometimes. With airplanes or other aircraft, sometimes you'll see a parachute, or you'll see the flaps on the sides kind of hop up, and the pilots all control that. So we know about turbulence too. If you've ever experienced turbulence, it's not fun, but remember sometimes the plane experiences turbulence. So when the air is flowing over the wings, they have to adjust things and make sure that it's able to deal with that. So lift can be reduced when the turbulence is causing drag. And sometimes you want drag. Like when the plane is landing, you definitely want drag. And you don't want it though when you're trying to be able to move at a high speed through the sky. So pilots are well versed in how to handle all of that. So they use those flaps and all sorts of different parts to be able to increase the lift and make sure everything is handled. So we also have what's called Pascal's principle, or Pascal, depending upon how you pronounce it. So he said, a fluid in equilibrium contained in a vessel exerts a pressure of equal intensity in all directions. So if you remember a few weeks back when we were talking about balloons, when you blow up a balloon, the pressure is exerted in all areas of that balloon evenly. So it's not like one side experiences more. In our everyday lives, we have brake systems in our cars, hydraulic lifts that might lift the back end of like a trailer or something up to carry things in and out of like a big semi. We use hydraulic lifts in lots of different ways, but they all use this idea, the fluids. There's even brake fluid or hydraulic fluid that we put in cars and different things to make sure that that is what's happening. So that would be something that we could see in our everyday lives. So they showed you at the end the brake system, right? So by the touch of a foot on the brake in your car, you are forcing the small piston to give pressure on the brake fluid right inside our brake system. So that change in pressure ends up allowing you to be able to exert evenly on all four of those wheels, right? So everything is being exerted so that not just one wheel has the brake being applied, all of them do. And that's obviously a safety thing too, because you don't want to have, the front only working or the back only working. Maybe you've experienced that on your bike before. If you only use one of the brakes, that can be pretty dangerous. So we use this to help things be able to be exerting that pressure evenly. So we will have a couple different ways to explain this in a lab that'll help us do that even better, but let's come back together.